Hello, I'm Hussein. I'm a PhD student under Dr. Alex Thompson at Mississippi State University, and I started my journey as an agricultural engineer 18 years ago in 2003. My grandfather was a farmer, and one of the main crops in his village was lentil. But since lentil was short-legged, it should be harvested manually. So I got my first inspiration and I designed a machine that could root out the whole plant. Then I optimized the machine to make it ready for field tests. We conducted multiple field tests and they proved that the machine should be motorized and bigger than that. Also during my bachelor's, I designed this simple semi-automatic CVT that its output speed was adjustable. Since I was determined to solve the short-legged lentil harvesting problem, I got a loan from a bank and I continued the project. The machine that I designed and fabricated had 3 independent units and it was mounted in front of a tractor, but the problem was that the machine was too heavy. In 2009, I established a company in the Science and Technology Park, and also I rented a garage to continue my research. This time I designed a very light lentil harvester, and I could test it for 2 consecutive years. After performing too many tests and optimizations, I found out that root out mechanism is not the solution. And here is another project, a pruner that I designed to pick delicate fruits. Later on, I did my master's and I gave myself the last chance to solve the short-legged lentil and chickpea harvesting problem. This time, I designed and fabricated a cutter bar harvester header with resistant and flexible blades. The machine worked really well. After Masters, I worked for Iran Tractor Manufacturing Company, and during that time, I designed the chassis and the double plate clutch mechanism. In 2018, I came to the United States and I started my PhD in Biological and Agricultural Engineering at Texas A&M University. And that was the start point of being engaged with electronics and computers in agricultural engineering. One of the projects that I did was under canopy cotton imagery. I attached a flare camera to the Jackal robot at a very low height and I gathered thousands of under canopy cotton images of more than 20 different cotton varieties. Another project was assessing the feasibility of in-field ginning, and we found out that it's not feasible yet because of too much energy demand. My main concentration is to design an end effector that can pick the seed cotton, and it will be worked in conjunction with a robotic cotton harvester. The project is funded by Cotton Incorporated. Multiple ideas have been assessed and we made prototypes of some of them. The best idea so far is a multi-finger end effector. We conducted lab and field tests and the results are promising. Since my supervisor Dr. Thompson got a new position at Mississippi State University, I followed him and I transferred to MSU in 2021. My research objective is the same though. To test my end effector more precisely, I made an aluminum platform and installed a system of 3 linear actuators on that. The end effector is attached to the Z-axis. The ultimate goal is to design an end effector for the robotic cotton harvester that can pick the seed cotton at high speed and efficiency, consuming low power. During these years, I learned a lot, and I know there is much more to learn in the future. But as an agricultural engineer, these are some of the key things that I learned so far. Be patient. Look at the problem meticulously. While working on a project, sometimes it's better to stop and look at the route that you're going. Most of the times, there is a simple solution for a complicated problem. If I listen carefully, I can learn something even from a layman in a village. Computers and electronics can help us to make better machines with less effort. Also, the future of the agriculture is closely related to robotics, and that's why I'm learning these skills all the time. Take risks as much as you can, because that's the only way of being innovative.